Page 183, number 21. F of x equals 2x cubed plus 3x squared minus 12x. Polynomial. Usually these work out very nice for this type of problem. And you can see why. You know what a cubic looks like. This thing sort of looks like that without putting any extra pieces on there. So there's increasing and decreasing and probably a max and a min. We'll see what happens. Let's read the directions here. Part A, critical numbers. Part B, increasing and decreasing intervals. And then part C, relative max and min. And that's nice that it walks you down the path, because if you want relative max and min, the only way to get there is to find those other two things first anyway. So by asking them, it's kind of helping you follow the path here. All right, so critical numbers, that's where f prime is 0 or undefined. So 6x squared plus 6x minus 12. That's not undefined anywhere. It's a polynomial, so it's defined everywhere. But we can set it equal to 0. I'll factor out a 6 to make life a little easier when it comes to factoring. X plus 2 and x minus 1. So x equals negative 2 and x equals 1. Our critical points. We use the critical points to set up the number line to find the intervals. Again, please put them on in the correct order. Negative 2 is in fact less than 1. And then we'll pick some values on those intervals to check into the first derivative, because the first derivative will tell us if it's increasing or decreasing, and that will tell us, it will tell us if f is increasing or decreasing, and that's what we're looking for. So f prime, I've got options up here. I can plug it into the polynomial form, which would involve a lot of working things out. I think I want to plug it into the factored form, because that's going to be a lot easier. So 6 times negative 3 plus 2 times negative 3 minus 1. Again, I don't really care about the numbers. I'm concerned more about positives and negatives. So 6 times negative is positive. That means f is increasing. Plug in 0, get 6 times 2 times negative 1. That's negative. That means, so if f prime is negative, f is decreasing. I'm pretty sure I know what the next one's going to be, because I know what a cubic looks like. But let's show the work. 6 times 2 plus 2 times 2 minus 1. That's all positive. So f prime is positive. That means f is increasing. So the picture is not the answer. I mean, it sort of contains the answer, but the picture doesn't qualify as the answer. You have to say it's increasing on negative infinity to negative 2. And then from 1 to infinity, it's decreasing from negative 2 to 1. So make sure you include the statement of where it's increasing and decreasing, not just the picture. Like, if you leave the picture, you've done all the work, you just haven't quite said the answer. It's a little bit like if I ask you to add 5 and 7, and you say, okay, I'll add 5 and 7. There it is. Like, well, yes and no, right? Like, you haven't quite given me the answer yet. All right, got our intervals. Relative max and min. Well, again, I can pretty much tell from the picture. but I need to get the actual answer. There's a max at -2 something. Actually, let's see how this is worded. Because if it just says location or where, then we'd be done. If it wants to know what the max is, I need to find the y value. Part C, apply the first derivative test to identify all relative extrema. All right, it's not real clear, so let's give both. That way we'll know we're okay. So I need to find the function at -2. So I got to go all the way back to the original function. Plug it in -2. Let's see, that's 36 minus 16 is 20. A relative min happens at x equals 1. Let's find the y value there. So 2 times 1 plus 3 times 1 minus 12. 5 minus 12 is -7. So lots going on all those problems. Critical numbers, because that leads to a number line, so you can figure out where you're increasing and decreasing. And when you know increasing, decreasing, then you can spot max and min. And where we're headed next week is to graph one of these things, because these key points would go on a graph, and we know what's happening in between them. So we'll start to be able to put all this information together and do a graph of these. But not quite yet for the graph.